So we learned that the dissociation constant of the pure water at 25 degrees Celsius at around room temperature is about 1.0 into 10 to the power negative 14, which means that the hydrogenamine concentration, hydroxyl concentration for the pure water at 25 degrees Celsius is 10 to the power negative 14, which means that H3O positive ion concentration will be 10 power negative 7, and hydroxyl ion concentration again in the pure water will be 10 to the power negative 7. This is what we have learned. Now if you want to compare the other solutions with the water, suppose we take here the lemon juice. Okay, the lemon juice actually contains how much of the hydrogenamine? The hydrogenamine concentration for the lemon juice is about 10 to the power negative 3, right? So you can see that the hydrogenamine concentration in the lemon juice is much higher than the water. So you can easily say that this is having a more hydrogenamine concentration, means it should be acidic, correct? It should have a more acidic character than the water. So comparing water and the lemon juice in terms of hydrogenamine concentration is the one way. And if you take another example, let's take the example of let's take the seawater. The seawater actually has a hydrogenamine concentration is about 10 to the power negative 8. And again, if you compare it with this one, you can see that it has a lower concentration, right? Lower concentration of hydronium ions in the seawater. And if you look at your the black coffee, right? The black coffee that we take, coffee that we take actually has a hydronium ion concentration, H3O positive concentration, about 10 to the power negative 5. Okay, again you can see the black coffee has a much higher concentration of the hydronium ions as compared to the water. So comparing basically the H3O positive ion concentration like this is not a very convenient way. So Sorensen in 1909 actually gave us a different way of comparing the hydronium ion concentrations of the different solutions. Okay, so that is what you call as a pH, so which is a power of hydrogen. So pH is actually negative log of the H plus ion concentration, and you can see that this is a much better, much easier way of comparing the different solutions. Let's compare the pH of the water. For the pure water, we know that it contains the hydrogen ion concentration 10 to the power negative 7. Therefore, the pH of the water will be minus log of the 10 to the power negative 7, which is equal to 7, right? So that means for the pure water, the pH will be 7. Now look at the lemon juice. The lemon juice contains 10 to the power negative 7. So therefore, you can say the lemon juice will have a pH of a negative log of the 10 power minus 3, which is 3, right? Which is 3. And similarly, you can look at the seawater, right? So seawater will have a pH of the negative log of the 10 to the power minus 8, so which is 8. Means that you can now easily compare the solutions in terms of the pH, because you get some real numbers over here, right? You got the 7, you got the 3, you got the 8. So this is a much better way of comparing the different solutions in terms of their alkalinity or the acidity.